Hello friends, very good evening. Myself Dr. M.H. Channaya, and in today's video we are given with a sketch of three different solids standing one over the center of the other, and we are required to find out or to draw the isometric projection of the combination of these solids. And let's see what are they. The bottommost we have got 100 is cube, so it has to be a square with 20 mm height. That is, it is a square block like our square prism. And over that we have got a half sphere, that is a hemisphere standing with its curved periphery in contact with the top surface of the square block. This is how we should analyze. And above that, friends, exactly at the center of the top flat surface of the hemisphere, you have a cone resting, and this cone has a diameter of 60 and height is equal to 50. So we are required to draw the isometric projection. Friends, whenever it is isometric projection, we have to make use of the so-called isometric scale, in which whatever the dimensions are given there are to be multiplied by 0.815 to convert the actual length to the isometric length. Friends, let us commence the projection of this isometric projection from the base of the solid. In the base, we have got a square block 100 mm by 50. So, friends, I'll just take a reference line, mark a point. On this, I am going to mark a distance of 100 ISO. When I say 100 ISO, the total length of 100 is to be multiplied by 0.815. So it's actually 81.5 millimeter. Similarly, on the other end also you will have the same thing. Now friends, let us draw the isometric projection of this block. So what is to be done? I am going to draw these two lines at an angle of 30 degrees to the horizontal, and through every point I write a vertical line of height is equal to 20 mm. That's given there. So I will call it as 20 ISO or ISO 20 is the height of that block. So friends, I can simply draw some thin lines to show the top surface of this block. So something like this. Again a line from there. So this will represent the isometric projection. I have not darkened it yet. So this is a vertical line and again a vertical line here. So this will represent the isometric projection of the square block which has got a thickness of 20. Friends, exactly in the center of this, you have placed a hemisphere with its curved periphery in contact with the flat surface of the square block. So what is the height, friends? Diameter. See, this height is not given. This is diameter is equal to 80. So this height is going to be 40. So from here, at all these points, I should take a height of 40 millimeter. That is isometric height. That is, this 40 millimeter height is to be multiplied by 0.815. And friends, say this is the block you are going to have at all this. That is 80 mm. So from here, I can just construct a box, and this box has got a dimension of how much? This is at the top is 80 millimeter. So how to find this, friends? If it is 80 millimeter, this is 100, this is 80 at the top. Yes, it is correct. Now friends, I have to leave a gap of 10 millimeter on from all the edges. This is 10, this is 10. So this will be what is called 80 plus 10 plus 10. This becomes 100. Similarly, here you should leave a gap of 10 here. So you are going to get 80 for this rhombus, whatever you get here, bigger rhombus. So that bigger rhombus is the top face of that. So in the isometric projection, this hemisphere, top surface, appears as an ellipse. So I have shown this by these lines, friend. This line, this and this. They have measurement of 80 millimeter. Friends, now to obtain the isometric projection of that circular face, the method is very simple, friends. Please follow carefully. I will take this one end of the parallelogram as a center and join that to the opposite side center. Opposite side is this length, and I am going to take this center there, join to this. Please listen carefully, and it's so easy. Friends, when you join this corner or point 1 with this, you see this cutting the horizontal diagonal at center 1. So with center 1 and radius equal to this much, I am going to draw an arc. As an arc I am going to draw. Similarly, friends, taking the same distance on the other end with the same radius, I will draw the second arc. So these two are drawn from center 1 and 2. Friends, this corner is center 3 with center 3. And this radius, I am going to draw the third arc. So 1, 2, 3 over. Similarly with the center C4 and radius equal to this much, I am going to draw that. So this is the top surface of this hemisphere which appears as an ellipse. That ellipse we have drawn, friends. Now, friends, on the center of the top face of the hemisphere, we have got a right circular cone resting exactly at its center. So friends, for this base of the cone also, we are going to get a similar ellipse. So how it is to be done, friend? This is 80 and this is 60. There is a gap of 10 millimeter left on all the sides. So friends, I have written once again these lines at a distance of 10 millimeter, at a distance of 10. So friends, we are going to follow the same procedure and obtain another ellipse parallel to that previous ellipse. Friends, this is how approximately you are going to obtain this. And friends, now to obtain the apex, that is O, the corner at the top of the cone, we have to take this height. Height is equal to 50. 50 dimension is to be converted into isometric length by multiplying by 0.815. It comes to approximately 42 mm. So I locate this point O. So this is the apex of the cone. Now friends, we have to draw the complete isometric projection of these, friends. Now let us start from the top face. Friends, in the top face we have this bigger hemisphere. Hemisphere is here. So let me draw that hemisphere first. And for this hemisphere, we have the center is this point. No, now in all the isometric projection, we have to take that center of the hemisphere as the center and radius equal to the actual radius, that is diameter by 2, 60 by 2. So 30 mm I should take, and friends, I should complete a draw an arc with this center so that this will be approximately like this. Friend, this is going to be the center of this. So ellipse you have got here. Now friends, for this we have to join this by writing lines tangential from the apex to this line or the center of that. That is 60 mm diagram. I am going to draw a line tangential to this. Similarly, friends, another line tangential from there to the same ellipse. So we will draw another line from there. Friends, we have completed the isometric projection of this cone. So here, friends, in the cone, you don't see this part because that is hidden, and even you don't find this line there. So this is how the cone is going to stand. This is cone is having, so the hemisphere is having this length. For the hemisphere we should draw now. Now friends, on the same lines, we have this hemisphere. Now taking the same center and the height or the radius equal to the actual radius, that is 30 mm, I am going to draw one more line, one more circle or an arc of a circle. Friends, remember, whatever this arc you are drawing now is going to be parallel to the edges of this solid. That is to say, this ellipse you are drawing for the hemisphere, this is parallel to this. So these two are parallel to each other. And again, friends, we don't see this part inside that. So let me rub this portion. So friends, you can see here, after I remove all these lines, you will have the curves drawn parallel to each other. So this is how the cone appears, and this is the hemisphere, friends. This hemisphere has got the center here. Now with the center of this hemisphere and taking the actual radius, I am going to draw an arc or a circle which is tangential to this larger diameter. Friends, say it is something like this. Friends, this is how it is going to appear when you draw the circle tangential to this. So we have taken the actual radius to draw this circle. Friends, finally after completing this, we have to show the bottommost box, that is the rectangle or square prism having thickness equal to 20. So friends, if you observe it carefully, we have to darken the top surface of this, top surface of the square box. So this is another line, another visible line from this corner, and all this are to be shown by dark lines. This of height 20 ISO, and friends, from all this again we are drawing lines parallel to that. So we will get a figure like this, friends. So again, finally I am going to draw or join these two. So friends, this figure will give you the isometric projection of the combination of solids wherein a hemisphere of diameter 80 millimeter is resting on the top surface of a square block of thickness 20 mm, and exactly on the center of the top face of this we have got a right circular cone of diameter 60 millimeter and height 50 mm resting on it. So friends, to make this drawing look little meaningful and nice, we have to remove all these unwanted lines. So I am going to remove all these unwanted lines, in the sense the construction lines, so that your drawing will have a good look compared to that without that. Now friends, let me complete this drawing. So this is the height we have got, this length I have to join, and whatever the invisible edges are there, we do not show them in isometric projection and also in the isometric drawing. Now friends, you can see the complete isometric projection of the combination of these solids. This is how we look friends. And remember, in the isometric projection, we never show any angle or any of these dimensions. It's a convention that's being followed. Friends, this is how finally it appears. Friends, you have seen that we have drawn the isometric projection, that is isometric of these combination of solids, wherein you have got a square block and the center of the top face is resting a hemisphere with the curved periphery in contact with the top flat surface, and over the flat surface of the hemisphere we have a cone resting exactly in the center. That is to say, the axis of this cone and the center point of the hemisphere and the axis of this square block all lie in the same plane. That is to say that they are collinear. Friends, I hope you have followed the isometric projection of the combination of these three solids. Please go through the complete video, and if you like this video, do share this video and the information about my YouTube link, that is Engineering Drawing by Dr. M.H. Annaya, to all your friends. Thank you very much for watching my YouTube video and have a blessed evening.